Experiment number 2. Acetic acid concentration and equilibrium constant K sub A. In this experiment, we will titrate a solution of acetic acid to determine its concentration and K sub A. A titration is any analytical procedure in which increments of a known reagent solution are added to the alide until the reaction between the alide and the titrant is complete. In this experiment, the titrant is sodium hydroxide. The analyte is acetic acid. Over here we have the structure of acetic acid. This hydrogen is acidic. The chemical reaction between acetic acid and sodium hydroxide is written here. We can also write out the ionic equation. Sodium hydroxide decomposes into sodium plus and OH minus. And over here, this is sodium acetate. It decomposes in water into the acetate ion and sodium plus ion. If you look at this ionic equation, we see sodium plus that appears on the left and right. They cancel to get the net ionic equation. What is a scout titration? A scout titration is simply a fast but inaccurate titration that gives you a rough idea how much titrant is needed before you begin the actual titration. Performing a scout titration saves time. In this experiment, we're going to look at, again, the reaction between acetic acid and sodium hydroxide. The completion of this reaction is indicated either through the color change of a pH indicator or through a dramatic pH change on the titration graph on your computer screen. Sometimes we use both. We use a pH indicator in the solution, and also we use a pH probe to record the pH value of the solution and display the titration graph on a computer using a software called Logger Pro. Over here, this is a titration setup. We have a burette over here. We have a stopcock here. It's also called a valve. We have a flask. Sometimes we use a beaker, and we put this beaker on a hot plate because we want to use the magnetic stirrer to stir the solution. And over here you see a typical titration graph. We will use Logger Pro to display this graph on a computer screen. And you can see when we add sodium hydroxide into acetic acid, the pH is going to increase. There are two titration curves. One is scout trial. So this one, the solid line, is scout trial. It's not very accurate, but it tells us a rough idea about where this endpoint is. So it's roughly 25 milliliters. And then we do the accurate trial. We can add sodium hydroxide really quickly, all the way maybe to 20 or even 22 milliliters. And then we start to just add sodium hydroxide just drop by drop slowly, and we will get a more accurate endpoint or equivalence point over here. And then we can look up the volume of sodium hydroxide added into the solution. So again, this is the equivalence point of the accurate trial. Now there are some terms we need to define. What is the indicator? We often add a pH indicator for this kind of titration. A pH indicator often changes color when the reaction is complete. So we can tell, well, if the color changes, it's the equivalence point. Now what is the equivalence point? Well, the equivalence point means, well, the quantity of titrant added is the exact amount of titrant necessary for the reaction with the analyte. For example, if you have 1 mole acetic acid, then you need to add 1 mole sodium hydroxide to complete the reaction, and that's the equivalence point. What's the end point? Basically, these two are the same, but the end point is, well, reached when this equivalence point is reached by the visualization of, for example, color change of the solution. So these two in essence are the same, but equivalence point is the theoretical point. End point is the empirical point when the titrant reacts with the analyte completely. What is the half equivalence point? So let's say at the end point you used 20 milliliters of sodium hydroxide, and then the half equivalence point is where you use 1/2 of the 20 milliliters of sodium hydroxide. You need to look at maybe 10 milliliters, which is 1/2 of 20 milliliters, and you can look for the pH. All right, the pH value of the solution at this half equivalence point. And in this experiment, it's very important because at the half equivalence point, pKa is equal to pH. So you just look for pH, and then you get pKa. Once you have pKa, you get Ka. Well, Ka is just 10 to the power of negative pKa. This is from the Henderson equation. Now let me give you an example about the calculations. If we have 25 milliliters of acetic acid titrated with a solution of 0.2 molar sodium hydroxide, and we used 50 milliliters of sodium hydroxide, then what's the concentration of acetic acid? So really you need to remember 1 mole HAC or acetic acid reacts with 1 mole sodium hydroxide. So there's a 1-to-1 ratio. So that's why I set up this equation. On the right hand side we have the number of moles of sodium hydroxide. On the left hand side we have the number of moles of acetic acid. There's only one variable here, so we can solve this easily. It's 0.4 molar. And also from this 0.4 molar we can determine the mass percent. It's pretty simple because 0.4 molar means we have 0.4 mole acetic acid in 1 liter of water. And 1 liter is about 1,000 grams, so we have the mass of acetic acid on top. By the way, 60 is the molar mass. And then we need the total amount of solution on the bottom, 1,000 grams, and then times 100%. The result is 2.4%. for this numerical example. But what if the concentration of the titrant is unknown? So we mentioned that we need to use sodium hydroxide to titrate acetic acid. But what if the concentration of sodium hydroxide is unknown? We need to do standardization. What is that? We need to determine the concentration of the titrant first. In this experiment, we'll use a standard so-called KHP to determine the concentration of sodium hydroxide. There's a 1-to-1 ratio between KHP and sodium hydroxide. 1 mole KHP reacts with 1 mole sodium hydroxide. So this standardization is pretty much just a titration before the titration. Again, we're going to use KHP to standardize sodium hydroxide solution. It's a titration before the titration. So we're going to use KHP to titrate this sodium hydroxide solution. And then we'll use this sodium hydroxide solution to titrate the acetic acid solution. This KHP is actually potassium hydrogen phthalate. It has a molar mass of 204.22 grams per mole. And we need to use this number later because we're going to weigh KHP, and the mass divided by molar mass, we get the number of moles. And the number of moles of KHP is the same as the number of moles of sodium hydroxide. Here's a numerical example. Let's say we have 0.325 grams of KHP. And we use sodium hydroxide to titrate KHP. We used 15.77 milliliters of this aqueous sodium hydroxide. Now, what's the concentration of sodium hydroxide? Well, it's pretty easy because we just need to determine the number of moles of KHP first. We have the mass, we have the molar mass, we determine the number of moles. And then there's a 1-to-1 ratio between sodium hydroxide and KHP. Therefore, the number of moles of sodium hydroxide is also 0.001591 moles. Now we have moles and we have the volume in liters. Alright, we can convert milliliter to liter, and then we calculate the concentration of sodium hydroxide, roughly 0.1 molar. And then we'll use this sodium hydroxide solution to titrate the acetic acid solution. So again, 2 steps. We determine the concentration of sodium hydroxide first, and then use this solution to titrate acetic acid. Safety. Sodium hydroxide is caustic, so if there's any spill of sodium hydroxide on your skin, rinse for 15 minutes. And we'll have dilute acid and base solutions. They are irritants. And just for your convenience, during the lab period, always can go into a labeled waste beaker. So you just put a label on it, says waste. At the end of the lab, you can dump all the waste into the waste bottle in one of the fume hoods. Some of the videos I'd like you to watch. Again, over here, this is a playlist that includes a lot of videos for Chemistry 183 lab this quarter. But particularly for experiment number 2, acetic acid, I'd like you to watch a video on preparing a burette, reading a burette, the titration skills, and a video on pH probe.